We have a test on Friday.
Yeah.
Okay. All right. Shh. I'm recording right now. You can say hi, by the way. Hey, by the way, Zach, when you print, you need to not print and run away. You have to wait for it to start to print. I turned it off because it wasn't the first layer wasn't laying down well. So you got to make sure the first layer prints, and before you go, because it'll just like spin a bunch of just plastic, you know. All right. So go back. I turned it off. You'll have to reset. You'll have to put some more acetone and ABS mix on the table. You can ask the printer guys if you need help with that, and then you get it printed. All right. Okay. So where we left off Thursday. Now it's been Thursday. We did a couple of problems. Is that right? Did we? Okay. Where did we get in that problem? Did you guys work it yourself?
Yeah.
Okay. So this, if I remember correctly, and I apologize because it's been a little bit of time.
Yeah, there's that one. There's a ball.
Okay. There is a ball here. It's a very lumpy ball. And what did we say? We said that the ball did one of these things, right? Essentially. But we talked about ignoring the horizontal velocity, right? For the moment, because I want to focus on just one aspect at a time. What did we say the initial velocity was?
10 meters per second.
Was that straight up or was that angled? Okay. So this is our Vy initial. So Vy initial. I'll either put 0 or I for initial, and I apologize. I go back and forth. I've used both before. So it's 0 meters per second upward. And then what else do we want height here?
10 meters per second.
Oh, 10 meters. Oh, I'm sorry. Excuse me. 10 meters per second. Okay. Positive, right? Not negative. It's positive. Positive means what?
Upward.
If it was going down, it would be, okay, did I give you a height? 25 meters. Okay?
You use 4 points.
Oh, yes, I did, didn't I?
Yeah.
So this is,
That was point 1.
it's point one. Did I label on 1? Point 1, okay. So this is point 1. This is point 2. This is point 3.
4 was at the very
4. Okay.
No, there was one in the middle.
Yeah, you got rid of it.
We got rid of it. I think I got rid of it. I think I got rid of it. The one that was in here in the middle, between 3 and 4 was gone. I think I.
So now we need to do volume 4.
Okay, so what do we say? so we know. So and this is going up to this point here where we have the center line for these points. That's our 25 meters. Okay. So what was it we were asking? What was it we were asking? Okay. So I wanted Vy at point 1, Vy at point 2, Vy at point 3, and Vy at point 4, right?
We already know
And we also wanted T. We also wanted our T at 1, T at 2, T at 3, and T at 4. Is that all I asked for? Okay, and then I want to know that the height, the height of point 2. That's a lot of stuff to find out, isn't it? It's a lot of stuff. Okay, well, it's not that difficult to get this. Did everyone get an answer? Did everyone get through this?
Yeah.
What now?
I don't know if it's right or not.
Okay, who got an actual answer at some point? Okay, I only got one. Did you guys need more time to work on it? We can. Here's okay. I'm happy to go over it. Look, I'm happy to go over it, and I will go over it. And eventually, I'll go over it no matter what. My concern is that here's my concern. My concern ultimately becomes that if we continue down the path of me just going over and you not doing, not that that's what's happening, but if we go down that path, then you guys don't get to actually do the problem. So that's where I don't want to leave. Okay.
But like, yeah, if you don't know how to do the problem, start with.
Okay. So let me give you a head start on. Okay, let's do that. I like that idea. Okay. So here's the thing, and I want you to struggle through this. Look, I want you know what. Let's think for a second. Well, take it one step here. I want you to struggle through it because I want you to learn how to do it. I'm going to give you a hint on one piece of it, and I want you to finish the rest. Okay? We're going to follow our process. Everyone up there on the far right, you see the process? Problem-solving process. Number one is what? Have we drawn a picture? Yes. What's our next thing we need to do? Lay out our facts. So the first question, in these types of problems, the first question you want to ask yourself, does anyone know that first question?
What are our facts?
Hmm?
The initial?
No. The first question you want to ask is, what kind of motion do you have? Okay. Is it vertical motion? Is it purely vertical? Purely horizontal? Is it a mixture? And in each of those directions, is it constant velocity or constant acceleration?
Purely vertical,
Okay.
constant acceleration.
Okay. In which direction is that constant acceleration?
Negative.
Down, right? Due to what?
Gravity.
Good. Now there will be times where I might say we're traveling at a constant velocity for such and such, and then we accelerate. But those are two separate problems. Okay, does that make sense? So even though you get a problem where it's a mixture, you need to break them down into this constant velocity and constant acceleration. Why do you have to split them up into those two different types of motions?
Because they have different equations for each one.
Right. They're on a purely tactical manner. They have different equations that are valid for each of those cases only. From an understanding standpoint, acceleration is completely different than velocity. Why? Constant acceleration versus constant velocity. What's the difference? What's the difference between constant acceleration and constant velocity?
Constant velocity means you're moving the same speed. Constant acceleration means you're changing your speed at the same rate.
Good. Very good. Everyone should be able to. I should be able to pull the string on all of the teddy bears here, and you should all be able to speak that. You get that? Pull the thing and just right. You should be able to say, "What's the difference between?" Pull the string. You guys should be able to repeat that. All right. You should understand that constant velocity means that you have your cruise control is on. Constant acceleration means that you are accelerating. Your velocity is changing in a constant manner. Okay. So that's the first thing you. So in this case we have purely vertical motion, and we have constant acceleration, right? And what's that constant acceleration due to? Gravity. So what do we know about the actual value of gravity's acceleration? That was okay. Meters per second squared. All right. So we know that. What else do we know from this scenario? We know that our initial velocity is 0. We know that our acceleration of gravity is that. What else do we know? Okay. So the height between 3 and 4, okay, is a positive 25 meters. Now, I said that specifically, between 3 and 4, okay? That's 25 meters. All right, or actually, let me take that. Let me say final minus initial. Let's do it this way: 4 minus 3. Final minus initial. Yes, 3. Positive 25. I'm doing it from that standpoint just to say that, hey, if my final is here, I'm going up. That's what positive 25. If I was going the other direction, it would be negative. Your negative signs, you have to be careful about distance because distance, isn't absolute. It can be an absolute. It's all relative. Like, is it coming towards me? Am I going away from it, right? So be careful about that. What else do I know? There's one more piece of information that you know. No, actually, let's hit that. No, and let's hit that. That's a common misconception, and only because you're looking too far in the future. Anytime we're giving these problems, and you're asked the velocity at contact, that's the velocity the instant before it hits, not after it hits and stays stable. Does that make sense? But a lot of people make that misconception at the beginning, but let me just be very clear about it. At point 4, it's the instant right before it hits, so it still has velocity, or the instant that it hits. What's the other piece of information? Because we don't know that velocity yet. But what's the other piece of information we do know?
Velocity to 0.
Okay, velocity in which direction? Up. So we're going to call that Vy. So Vy, okay, so Vy1 and Vy2 equals 0 meters per second. So notice that you see how I'm putting the y. Why am I putting the y in here? Why am I starting to do that? And you should be doing this as well. Why am I doing y? Because it's vertical. Because at some point we're going to get what? We're going to get a problem with both vertical and horizontal. You need to know the difference between the two. Get in the habit of using Vy right now, because when we start to do, once this ball shoots off at an angle, you're going to have to do both sets of calculations with y and x. You don't want to confuse which one you're dealing with. Okay? So make sure you use Vy. So we know that information. Is there anything else we know? No, I think we're pretty good. We're pretty good. But we have some equations that we can use for constant acceleration. What are those equations? Say that one more time.
The final velocity is equal to the v naught plus a times the delta t.
Okay, so our final velocity is equal to our v initial plus a times delta t, right?
Yeah, it's 2A, right?
Just a. You're looking at the squared version. And listen, this is but where, guys, where does this come from? By the way, where does this come from? Where does this equation come from? Back this out. What simple equation is this really a different form of? Yeah, this guy right here, that's our delta v term. Right? You guys see that? So it's really acceleration equals delta v, acceleration is delta v over delta t, same thing, right? So that's where that, so be careful, that's exactly where that's coming from. What's the next equation that we could potentially use?
Delta D equals 1/2 A times delta T squared.
Right? Okay, we've got that. What else do we have at our disposal? We've got two other big ones that we could deal with.
Change of x is equal to
Or change of distance is equal to, well, and really the change of, go ahead, keep saying, change of distance is what? Equal to what?
the constant velocity plus the constant acceleration. That's what I was saying. The change of x.
Okay, so well, we're missing some stuff here. So look, here's the thing, right? What does this really mean? The delta distance is equal to 1/2 a times delta t squared. What does this represent? Our distance for what? Okay, and for constant acceleration, an example might be the distance that we travel at a constant acceleration for a certain amount of time. You see what I'm saying? So it could be the distance I'm going to travel when I free fall for a certain amount of time. Does that make sense?
Yeah.
Okay, so keep that in mind. I want you to understand these equations. But really, there's some missing terms here. That assumes what? What does that assume? What does it assume about our motion?
Oh, that it's linear.
It assumes we have a constant acceleration, but it assumes, think about the beginning of this acceleration. If I'm going to change the distance, right, and I'm going to accelerate, all right, this assumes, and I don't want my, there's an assumption here. Let's think about this. Okay, if I were to drop a ball versus I would throw the ball down. Drop a ball versus throw it down. What's the difference?
Assuming there's no initial velocity. Yeah.
Huh?
It's assuming there's no initial velocity.
Exactly. Assuming there's no initial velocity. Because again, when we think about this, right? Velocity versus time, the change of distance is here under the curve, right? But if it's up here, There's
Square or rectangle.
there's a rectangle portion plus the triangle portion, right? Because you're going to be traveling a certain amount of distance at that initial velocity as well. So there's a v naught times delta t. Now Kaylee was right, but the one thing, and whoever said this equation initially was right, but let's be very clear in the fact that we know that is only right assuming that there's no initial velocity. Does that make sense? Everyone.
That's the equation that I was getting to, the delta t, because I have it written down as delta x equals the constant velocity equation plus the constant.
Okay, and I think I think you were getting there. I just wasn't hearing
it's
this
the same
portion.
thing.
Yep. Okay. Good. So delta t, right? And that you'll see this in your book as x final equals x naught plus v naught delta t plus 1/2 a delta t squared. You're going to see that in your book like this. Well, what is this right here? Colby, what's that portion represent really compared to the equation above it? Nope. These two, the xf and x0. xf, x final, x initial. What does that represent? Okay, but up in the terms of this equation above, what is it up there? Our change in distance. Because what would I have to do to get this x naught over here? I have to say x final minus what? X naught. Well, that is what? Delta x or delta d, right? Okay. Pay attention, kiddo. All right, so one more equation we have at our disposal.
The VP,
Okay, v final squared equals what? Plus what? 2a times r delta d. All right. Now, this one is not as intuitive. There's a few more steps mathematically to get to this point. So this one is, I wouldn't expect you to understand the intuitiveness. I expect you to understand the intuitiveness of this, the intuitiveness of this, and the intuitiveness of this. You should be able to explain these equations. You should be able to explain these three equations on an exam. Hint, hint, wink, wink, nudge, nudge. Huh? Crystal. Yes. Now this guy here, I'm not going to ask you to explain because it's a mathematical derivation of some things, but which we did. But I don't want you. You don't have to explain it. I need you to be able to explain those guys. Okay. All right. So let's. I'm going to shrink this stuff down. Okay. I'll put that over here somewhere. I'll shrink this puppy down. Quiet. Oops. Okay. All right. So let's start working some stuff, okay? So how do we so let's think about this for a second, all right? So I'm asking you, this goes back to your original question, David and Etta, right? How do we start this, right? You didn't ask. Oh, you're good. Well, if you knew, why did you tell me how to do it? All right. So again, we've got vertical motion, constant acceleration, okay? We know all this stuff. We're trying to figure out a couple of different things. Let me ask you a question. The ball is going up at a certain velocity of 10 meters a second, right? Is that right? Is that correct? Okay. Once we reach point 2, so I'm throwing the ball up. Once it reaches point 2, what's my vertical velocity again? 0. And after that, what does that actually just act like? What's it the same as? Who said that last time? You just said that?
Yeah.
Say it again?
It's just a drop.
It's just a free fall, right? Once the ball reaches point 2, it's as if I just dropped it. What's the only force acting on it?
Gravity.
What force is acting on it between 1 and 2?
Where's the force from?
Force from gravity.
Once it leaves my hand, do I affect it anymore?
It's still.
That's not force. Okay? I've given it some momentum and energy, but the only time it has a force is from my hand pushing it. Once it leaves my hand, When it's once it leaves my once it leaves my hand, it's up to physics, right? The only thing dealing. Listen, if I threw it up and gravity wasn't affecting it, what would happen? It would keep going. Would it go? Let's say I'm in space. Let's say I'm in space. Let's say I'm in space, away from the Earth, no gravity, zero gravity. I toss it up. What happens to the ball?
It goes.
Does it accelerate or does it go at a constant velocity? Why at constant velocity? Why does it not accelerate?
There's no
No force acting. So in this case, after it leaves this land, after it leaves my hand and gets pushed up, there's no other force acting on it except for gravity. That's why it does what? Slows down until the velocity reaches 0. And at that point, I'm still only acting on that part, gravity. So there are a million ways to do this problem. Okay? And you can solve it. You can use one or two equations to solve it very quickly. Okay. But I want to show you the construct and make sure you understand the problem. So it may be a little longer, but at least you get it. Okay. And then we'll start dealing with shortcuts in a little bit. Okay. So let's assume it's free fall. If it's a free fall, let's see. If it was free fall, right? Could I figure out the time it takes to get to 4 if I knew the whole height? Could I? How do I get this height? How could I possibly get the height between 1 and 2, guys? How could I possibly get the height between 1 and 2? Okay.
You find how far it travels up in 1 second. Which should
Time it takes for the velocity to hit 0.
The time it takes for the velocity to get from what to what? 10 to 0. Okay. So what equation do I have that really simply could do that?
V final equals V initial plus A delta T.
Right. Which is essentially my acceleration equals delta V over delta T, isn't it? Right? If I know the velocity change, I know my acceleration, I can figure out my time. And then once I get my time, what can I do with the time?
Use that to find the height by using the other equation.
Right, I can use the time to then go use my acceleration piece, right? Okay, so if I said, okay, so let's look at that. So let's say that my delta V equals A times delta T, right? So my delta velocity is what? What's my final, what's my initial? Final is what? 0 meters a second minus my initial, which is positive 10 meters a second, equals my acceleration, which is negative 9.81 meters per second squared times my delta T, right? So now I can figure out my delta T. My delta T is going to equal what? Minus. This is a multiplier over here.
Yeah, it's 10. True.
Come on, guys.
1.
1 meters per second squared minus 10 meters per squared.
Wait a minute.
Okay, 1.0. 1.02.
I'm saying 1 times
That's what it is.
You don't have math.
I said times. All right. So what's that number, guys? 1 point what? Okay. That's the amount of time, by the way, to get to point 2. So time for point 1 is 0 seconds. Point 2 is.
Wait, what do you have? That's it, 11?
Sorry. 1.02 seconds.
11.
Right? Everyone with me?
Yes.
Okay. Now, how do you figure out your delta distance between 1 and 2?
You have the
You-
delta D over delta T.
What now?
If you do V equals delta D over delta. Or V
Okay, you're saying v equals delta distance over delta time. Let me ask you a question. Hold on. Hold that thought. David, what kind of motion is this for?
Is that for constant velocity? Okay, that's.
Because you know that, David, because it's got one v, not a delta v, and therefore you know there's no acceleration, right? Okay. That's okay. Let's get through these issues now. Now on the test. So I can't use that, but what could I use? I mean, now all of a sudden I have some time. I have some time between 1 and 2.
Delta D equals 1/2 A.
Oh, look at that. Delta D equals 1/2 A times delta T, isn't it? Right? And so now I'm going to say my delta distance is equal to 1/2 times what?
9.8.
Negative 9 point.
Yeah,
Excuse me. I'm sorry. Thank you. 9.1 meters per second squared times what? 1.02 seconds squared. Do you guys see that?
yeah.
Because now I'm just breaking this down. Look, the beautiful part is that these equations act the same, whether I'm going from point 1 to point 2, 2 to 3, 3 to 4, or 1 to 3, 1 to 4, 2 to 4, 2 to 3. It's all the same. Yes, sir.
Okay, so are we going from 1 to 2 right here?
Right now we are going. So this portion. Oops, excuse me. This portion is going from 1 to 2.
Okay, then what about the initial velocity?
Oh yes, thank you very much. Plus, thank you. Plus our initial velocity. Thank you very much. Plus our initial velocity times our delta t. Thank you. So plus 10. No, is it 10? Yes, plus 10 meters per second times my delta t, which is 1.02 seconds. I just got through explaining that, and then I forgot that. Thank you very much. So, again, what are you laughing at, Mr. Mayfield? All right. Yeah, so don't forget, guys, because you're totally right. We're going to be traveling that distance because we're having initial velocity on top of the deceleration. Okay? So now, let me go.
Sir, I don't get why you're down.
Say what?
Like, I don't understand when you do have that.
Okay, so, all right, okay, here we go. Our change in distance is equal to let me do this one. X final equals X initial plus V naught delta T plus 1/2 A delta T squared, right? And this really means this is our delta distance, right? Equals V naught times delta T plus 1/2 A times delta T squared. Okay. If we're moving, we're going to change distance, right? Velocity and time. Velocity and time. I'm going to do two different things. In this case, where I start at a zero velocity, initial velocity of 0, the delta distance is the area under the triangle, right? Okay. Because remember, the constant velocity would be the area under the square, right? However, if I'm starting at some sort of initial velocity here that's not 0, the area under the curve is all of this area. That's our delta distance, which is essentially saying this portion plus this portion. And we know that this distance is this guy right here. We know that, which is the same as this. And we know that this distance is this guy right here. Now, if I didn't have, and I forgot that we had an initial velocity, so I was like, oh, well, it's just 1/2 AT squared.
Wrong.
But I was wrong. Thank you very much, Mr. Maines, for correcting me and saying, hey, Mr. A, you have an initial velocity, so you're going to travel it anyway. So, again, this is that alternate reality thing I said, right? You're going to accelerate, you're going to travel this distance. But if you didn't accelerate and you were traveling at this initial velocity, you would have covered this amount of ground anyway. But then you're going to accelerate on top of it, which means you get extra distance on top. Does that make sense? Okay. Clear?
Crystal.
Beautiful. All right. Does that make sense? Okay. All right. So thank you for catching that before I went to the whole. Okay. So, all right. So let's figure this out. So my delta distance is equal. What's my number? What's my delta distance for this guy? Anybody? Anybody? 1 point.
Stalls about 0.1.
So 1.02 squared times 9.81 negative. Don't forget your negative sign. Oops, hold on. 9.81. 9.81 negative times. That was really weird. 1.02.
Oh, you said more.
Okay, divided by 2. All right, plus 10.02, right? Or 10.2. Thank you. Plus 10.2, right? So that's going to be 5.09 something. What?
It's 5.096.
Meters. Now notice the sign is what?
Positive.
Positive, because we went up. Okay? Do you guys see that? Because we are going, in this case, we're going a positive velocity for some time, so we're increasing our distance. But because our gravity is sucking velocity away, because it's going the other direction, that's going to reduce that amount of distance that we've gone. Does that make sense? Okay. The inverse of that would be, rather than decelerating, I would say accelerating, right? Okay. Now you've got that distance, what can you do? What can you do with that distance? So you have the whole, now you got the height here, so now what can you do?
You add.
Yeah, you can find.
All right. I want you guys to continue working this on your own now. Go ahead and do this. This is sort of the construct. You're gonna break it down piece by piece. And so our height, our delta D, which is h2, is 5.09 meters, which is the height of this from 1 to 2, which plus our 25 meters. That would be our height at, or our height of 2 from the ground. Okay, so what we're looking for, guys, shh. I'm sorry? My YouTube channel that I've sent out links to many times? Shh. You should. It's a great thing to subscribe to. Inquiring minds want to know. All right. All right. Shh. Quiet. Okay. So I'm going to... Okay. Well, it's Innovate TVS at gmail.com YouTube channel. I'm not sure. Okay. Shh. All right. So let's think about this for a second. So we know we solved for the height, right? We solved for the height, right? Originally, we did the delta distance from 1 to 2. So it's 5.09 meters plus our 25 meters. Plus the 25 meters. So the height of 2 is what? 30.09, right?
30.10.
Huh?
I got 30.10. That's just rounding differences.
30.09. Yeah, I think I'll just count off completely for yours. I'm joking. All right, so the height is okay. Shh. Okay, so that's the height. The question is now the things we need to know our velocities. Oh no. Well, we'll finish this tomorrow.